There are different methods to solve the linear systems of equations that we mentioned here for the confidence interval. If you remember, we used the inverse matrix solution in the previous example as well. But there is also QR factorization, which is more efficient, more advanced. Also singular value decomposition. So inverse matrix, as we said, we need to take the inverse, but usually inverse is a problem. So instead we can use QR factorization. This is not really the topic of this class in detail, but we will show some concepts of it, then move on. Although the description of these methods is beyond the scope of this text, we mention them here because they can be implemented with MATLAB. So we will show you the MATLAB codes to be able to implement it. How can we use it in MATLAB? Let's see. It can be automatically used in two simple ways in MATLAB. First, for cases where you want to fit a polynomial, the built-in polyfit function automatically uses QR factorization. So we showed this to you before, and if you remember polyfit, we said that it is actually finding the regression polynomial, but it is using QR factorization. So we are by hand using the Gaussian elimination, for instance. Actually, we are just using the formulation of A1 and A0, but MATLAB is using QR factorization. Second, the general linear least squares problem can be directly solved with the backslash operator, if you remember, in MATLAB. Recall that the general model is formulated as this, and with the backslash we can also solve the problem. And recall, we use left division with backslash operator to solve systems of linear algebraic equations where the number of equations equals to the number of unknowns. We did this already before. For general least squares, the number of equations is greater than the number of unknowns. So the number of equations can be greater than the number of unknowns. Then the problem is the systems are said to be overdetermined. In that scenario, when MATLAB finds this out, you basically enter the number of equations greater than the number of unknowns. Then MATLAB senses that you want to solve such systems with left division, then it automatically uses the QR factorization. So for the backslash, if the number of equations and the number of unknowns are the same, then it directly uses the Gaussian elimination you can think of. But if it is different, then it's using QR factorization. Let's show an example in MATLAB how to use this. In this example, we are going to use the MATLAB built-in polyfit function and the left division function actually to calculate the coefficients of the data below. So if you remember, we can use this data to be able to have a linear regression or a second order regression by using this formulation. And in this formulation, we said that the z's are calculated using some basis functions. And for the basis functions are determined based on the degree of data. In this example, we are going to use a second order degree. Maybe we can write it here as well. Second order polynomial fit. We will use. And for that, first, what we need to do is we need to determine, okay, what are the z values for this second order polynomial fit. The z values are actually for a second order polynomial fit. So a general polynomial fit with an m order, we basically have these values. So z0s should be x0, z1s should be x, and z2s should be x2s. Basically, we have this z matrix, but now the z matrix for second order polynomial is equivalent to simply z0s are 1s, 1, 1, up to 1, and this is the number of data. The number of data is here 5. And the others are, so that's because it's only 6 actually. Because it's only 6, we can just write them 1, 1, 1, 1, 1, 1, 1. And the second one, z1s, these ones are x's. So that's x1, x2, x3, x4, x5 and x6. These are actually these values: x1, x2, x3, x4 and x5 and x6. These values. In addition, it shows that for a second order polynomial we will have another one, z2, x squared, because in a second order we have the highest square, so we will have this too. Then we need to add this as the third column, and x1 square, x2 square, x3 square, x4 square, x5 square and x6 square. So these are the z values. We just write these values and squares of them here, and we will obtain this z matrix simply. Also, we will need to use these y's, and y's are these actually. These y values are these. We will write this in this way. So let's write these in MATLAB. In MATLAB, we can simply write the x's like this and y's like this. Then we can create a z matrix, this one, and we will have ones for the size of x's, 6 ones in the first row or in the first column. This is a column wise, we can think, or doesn't matter. And these x's are these. Also x squares are these. So it basically takes the x's and x squares as column wise, one column, second column, third column, like this. So this creates the z matrix. And we have y matrix and as well, so we can use this formulation now with the MATLAB. Basically, in MATLAB, we can use polyfit function first with x data and y outputs. It solves the second order polynomial automatically. Simply, this is y equals a0 plus a1x plus a2x square. So it gives us the coefficients, 3 coefficients, as you can see here. Now we can use the same using backslash operator, but we will use this formulation now. You can see here, this formulation is basically is solved by using backslash by isolating a's. So z's are these z's obtained here, and a's are actually a's have 3. So let me show that. The A matrix has A0, A1, A2, let's say. So 3 unknowns. 3 unknowns. And with 3 unknowns, you can see actually we have many 6 lines of Z's and 6 Y's. So the number of equations is higher than the number of unknowns here. You can think that way. If that's the case, MATLAB is using QR factorization rather than using the Gaussian elimination in this, and it solves this as you can see and finds the same results actually, but from an opposite order. Here this one is this, this one is this, and this one is this, so that we can obtain all the data using this ZA functions as well, using backslash operator. So but for backslash operator you need to formulate the Z matrix in a certain way as we showed here. Then you can solve the result using the QR factorization. In polyfit, on the other hand, you don't need to do this Z matrix. It automatically does inside in polyfit to solve it. So this is much easier actually. Just enter the data and solve it. But if you want to use backslash, you need to generate the equation system, then solve it to get the coefficients for this second order polynomial fit.